We will also talk about this. If Newton was alive today, could he have solved problems like dark energy? We will answer all of your questions and many more. But before we do that, let's address a question that has puzzled scientists for years. What is gravity? For centuries, we believed that gravity was a force, an invisible interaction between objects with mass. It was Newton who first proposed this idea and explained how planets orbit the sun because of a force that pulls them together. According to Newton, every object in the universe attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This explains why the Earth keeps us firmly grounded and causes the moon to circle our planet. But there is a problem with this theory. It doesn't explain why objects fall towards the Earth when dropped. If gravity is a force, shouldn't they just keep falling forever? In fact, Newton didn't believe that objects fell. He thought they just stopped in mid-air. That's why he invented calculus, which describes how an object would remain in mid-air indefinitely if left alone. But then came Einstein. In his groundbreaking 1915 paper on general relativity, he showed that gravity isn't a force, but rather a consequence of space-time curvature. Space-time curves around massive objects, and this curvature affects how other objects move through it. He proved that a spacecraft accelerating at 9.8 meters per second squared would create the same effect as the Earth's gravity. People inside wouldn't feel any different than they would on Earth. And objects would also appear to fall towards the floor as if the spacecraft were stationary. It is now called the equivalence principle. But wait a minute. Doesn't this mean that Einstein disproved Newton? No, not really. You see, Einstein's theory only applies to very small scales, or very large ones like black holes and neutron stars. On Earth, the difference between Newton's and Einstein's theories is too small to be measured. That's why we use Newton's equations to calculate orbits and trajectories for rockets taking off from Earth. Even NASA uses Newton's equations to calculate trajectories, even though Einstein's theory is technically more correct. So what's the deal? Why don't we use Einstein's theory if it's technically more accurate? Well, it's because Einstein's theory is so complicated that it's almost impossible to solve analytically. In other words, we can't derive exact solutions for most situations. On the other hand, Newton's equations are much easier to solve analytically, so they are preferred. In practice, however, Einstein's theory becomes increasingly important as the energy scale increases, meaning that it becomes essential when dealing with objects moving at high speeds or in strong gravitational fields. For example, GPS satellites rely on Einstein's theory to function accurately. Without it, they would drift by several kilometers each day due to time dilation effects caused by their motion and gravitational field. So what does this mean for us? It means that both Newton and Einstein are right. But while Newton's theory is more intuitive and easier to work with, Einstein's theory is more complete and accurate. Just think about it. If Newton had never existed, Einstein's theory would have taken longer to develop. After all, it revolutionized our understanding of space, time, gravity, and the universe as a whole. And if Einstein had been born in Newton's era, he might have spent his entire career trying to prove Newton wrong. Ironically though, Newton's laws were derived without the benefit of calculus, whereas Einstein used calculus extensively in his work. Therefore, some people argue that if Newton had the same tools and knowledge available to Einstein, he may have come up with the theory of relativity himself. It's difficult to say whether Newton would have been able to come up with Einstein's theory of relativity if he had the same resources as Einstein. However, it's clear that Newton's laws are a subset of Einstein's theory, so it's possible that he could have arrived at the same conclusion. Newton was certainly brilliant enough to do it. After all, he developed calculus independently from scratch and made groundbreaking discoveries in optics, alchemy, astronomy, and more. His work laid the foundation for many scientific disciplines, including classical mechanics and physics. And his contributions to science continue to inspire awe and wonder today. But the question remains, if Newton had all the tools available to Einstein, would he have come up with the theory of relativity? Unfortunately, we can't know the answer for sure. But it's a fun thought experiment that helps us appreciate the brilliance of both Newton and Einstein. Ultimately, both men were geniuses in their own right, and their contributions to science are immeasurable. Newton's laws revolutionized our understanding of the physical world and laid the groundwork for classical physics. Meanwhile, Einstein's theories of special and general relativity transformed our conception of space, time, gravity, and the universe itself. Both men changed the course of scientific history, and we are all the beneficiaries of their genius. However, we should not forget that the laws of physics aren't set in stone. There is always the possibility that they could be superseded by an even more complete and accurate theory. Who knows what other groundbreaking discoveries await us in the future? Now, let's go back to our original question. What is gravity? Real gravity vs. fake gravity. As mentioned earlier, according to Newton, real gravity is a force that attracts any two objects with mass towards each other. This force is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. However, Albert Einstein turned this around and said that what we call gravity is actually just the effect of massive objects warping space-time around them. This warping creates a kind of gravitational pull that affects other objects near them. To understand this concept better, imagine a bowling ball placed on a trampoline. The ball causes the trampoline to sag or warp in a small area around it. Now, if we roll a marble nearby, instead of bouncing off the ball, it will continue to roll until it reaches the point directly below the ball, and then it will start rolling away again. The marble didn't get pulled by the bowling ball. It simply followed the curvature of the trampoline. Similarly, according to Einstein's theory, objects don't get pulled towards massive objects like the Earth. Instead, they follow the curvature of space-time caused by the Earth's mass. So, which one is correct? Well, both are correct. Newton's theory of gravity works well on Earth and is easy to use, while Einstein's theory is more accurate but more complex. However, Einstein's theory breaks down at very small distances and high energies, such as those found inside atomic nuclei. At these scales, quantum effects become significant and cannot be ignored. This has led to the development of new theories such as quantum gravity, loop quantum gravity, and string theory, which attempt to explain the nature of gravity at very small distances. So what does this all mean? Basically, gravity is a complicated phenomenon that can be described by different theories depending on the situation. While Newton's theory is a good approximation for most everyday experiences, it is not the complete story. Einstein's theory of general relativity is more accurate, but it also has its limitations. String theory and loop quantum gravity are promising candidates for a more complete understanding of gravity, but they are still being developed and have yet to be confirmed experimentally. Ultimately, the true nature of gravity remains one of the biggest mysteries of the universe. What do you think? Could Newton have come up with Einstein's theory of relativity if he had the same tools and knowledge as Einstein? Let us know your thoughts in the comments section below. Also, please don't forget to subscribe and like this video. Thanks for watching.